Welcome to English for Professional Mechanical Engineers. My name is Yiji. In today's lesson, we'll talk about the final part, microfabrication. These are the three categories of microfabrication. So far, we have covered photolithography and deposition. We will move on to the third topic and focus on the second part of etching. This is the outline of this section, etching. So far, we have explained the meaning of etching and the two types of wet etching, isotropic and anisotropic etchings. We will focus on dry etching in this video, and it will include plasma etching and reactive ion etching. Now, let's look at plasma etching. This photo demonstrates a plasma etcher, which is an equipment to do plasma etching. So, what does it work? It can etch a substrate by plasma. But what is plasma? Before looking at its function, let's start by asking a question about plasma. Plasma is one of the four fundamental states of matter. So, what are the other three matters? The answer is solid, liquid, and gas. These are the fundamental states of matter, which can be seen on Earth naturally. On the contrary, plasma is matter in an extremely high energy state and cannot be seen naturally on Earth. So, where can we see a plasma material naturally? Here is a photo for a natural plasma material. Can you tell what is it? It's something you are very familiar with. Yes, it's the sun. The sun is a star at the center of the solar system. It's a nearly perfect sphere of hot plasma. As you may be aware, the sun is a high energy state. As a result, plasma is also in a high energy state. In addition, its energy state is higher than that of the other three states of matter, solid, liquid, and gas. So, plasma does not naturally exist on Earth. However, it can be created artificially and used a lot in the lab. Plasma is an ionized state of matter similar to gas. However, its energy state is higher than gas. Usually, it is made of ionized gases. In addition, the amount of negative charged electrons is the same as that of the positive ions. Therefore, plasma is electrically neutral. It means it's neither negatively nor positively charged. After explaining the meaning of plasma, right now we can move on to plasma etching. First of all, wet etching was most widely used in the past because it is simple and low cost. However, modern processes avoid wet etching and use plasma etching instead. Therefore, plasma is getting more and more popular recently. Secondly, plasma produces energetic free radicals, neutrally charged, that react at the surface of the wafer. Under such a high energy bombardment, the wafer surface will be etched or removed. Finally, since neutral particles attack the wafer from all angles, this process is isotropic. As you can see in the figure, the surface after plasma etching is also a circular smooth profile. Right, was that clear? So, I will move on to the next dry etching machine. This photo shows reactive ion etcher, or RIE. This equipment is put in the NCKU clean room. Probably we cannot see much from this photo. Now, let's look at the inside of the equipment. RIE is a type of dry etching by using chemically reactive plasma to remove material deposits on wafer. First of all, it also operates in a vacuum environment. Therefore, it is equipped with pumps to expel the air out of the chamber. Next, a pair of parallel electrodes supply energy for creating plasma. Wafers are held at the lower electrode, while plasma is bombarding from the upper electrode. To remove the unprotected part of wafer surface. Can you figure out the difference between plasma etching and RIE? How could they be different if both of them apply plasma to etch a wafer? Let's look at the photo on the next page, and then probably you can tell the major difference of these two methods. A high-quality RIE can reach a deep channel like you can see in this photo. The depth is about 40 microns, while the width is only about 5 microns. When the ratio of depth to width is high, it is called high aspect ratio. And the etch depths of hundreds of microns can be achieved with almost vertical sidewalls. This is a characteristic of RIE. Now, can you tell the difference between these two dry etching methods, plasma etching and RIE? These two figures were shared during plasma etching and RIE. Do you notice their difference? Right. Plasma etching has an isotropic etch profile, while RIE is an anisotropic etching. Even though both dry etching methods apply plasma to etch a substrate, RIE on the right hand applies more energy to reach a higher level of etching efficiency in one direction. Therefore, it can create almost vertical sidewalls. Okay, let's reflect what we have learned today. After discussing the meaning of etching and characteristics of wet etching in the last video, we focused on dry etching for today's lesson. Question of dry etching. What are the two types of dry etching? Okay, the answer is plasma etching and the reactive ion etching. Question of plasma etching. Modern processes avoid plasma etching and use wet etching instead. True or false? Alright, the answer is false. Modern processes avoid wet etching and use plasma etching instead. So it is more popular to apply plasma etching in the modern processes. Another question of plasma etching. Since neutral particles attack the wafer from all angles, plasma etching is isotropic. True or false? Alright, the answer is true. As you may see in the photo, plasma etching can reach an isotropic profile. Question of reactive ion etching. RIE can achieve almost vertical sidewalls. True or false? Okay, the answer is true. This is a photo of RIE with vertical sidewalls. For your reference, this is a table comparing dry and wet etchings. Basically, dry etching is more limited by high cost, but with high quality etching properties. On the contrary, web etching is cheap and easy to set up. However, it is difficult to control etching rates and profile accuracy. Okay, so this is the end of section part 2 of the introduction to micro etching. So much for today, and thank you for watching. Hope you have learned something useful from today's lecture. Have a good time and see you in the next one. Goodbye.